Hi folks, and welcome back to Math with Captain Rod. Making this video here to work us through section 1.7 here, and thank you for taking your time to do this before class. All right, well first of all, there we go, get scrolled up over here a little bit. Okay, so we're going to look at a couple of these. Use a graph to find the intersection of each set. So first of all, we're going to talk about a little bit about what we're looking at here. So this is the set of numbers between -4 and 2. And this soft bracket here and here means we're not going to be including those in the set. And then over here, this is the set of numbers between 0 and 3. Now this is a different type of bracket. I call these hard brackets. And the hard brackets here and here mean that 0 and 3 are in those set of numbers. Okay, this symbol right here, this is the math symbol for and. And what we're going to do here is we're going to graph these sets on a number line. I'm just going to do a quick little sketch here. And what we're going to be looking for is the intersection point, because we're looking for all the numbers that are in this set and in this set. So here's what that might look like. So -4 to 2 here. I'm just going to put a 0 here as kind of a marker. Okay, -4 is over here somewhere. What I'm going to do is put a circle on this at -4. Now you notice that I left the circle open. That's the math way of saying not including 4. And 2 is about here. And I'm going to put an open circle on 2. And then usually you just do something like this, like connect them. So here's one way to kind of graphically represent this. Right. Now we're going to take a look at this one, 0 to 3. Now, this set starts at 0. Right? So I'm going to put a circle here at 0, but it includes 0 because of the hard brackets. So I'm going to fill that in. And this set ends at 3, which is over here. There's 3. I'm going to put a circle at 3. And again, because it's a hard bracket, this is going to get shaded like so. Then I'm just going to kind of connect the dots. Boom. So the region where everything is connected, or I'm sorry, shaded, is this stuff right here. And that's from 0 to 2, including the 0, but not including the 2. And that's already written right here, so I'm just going to kind of call that done. Okay, so now, this next one, I'm going to go ahead, since I doesn't look like I wrote the answer down for it, I'll go ahead and do this one as well. So we're just going to do a quick little sketch here. I like to just kind of put a 0 here to kind of be a marker here. Again, this is supposed to be a number line. This set on the left right here from -1 to -infinity. So I'm going to go to -1. Now, soft bracket, so open circle. Right now this -infinity here, the way I'll represent that is just with an arrow. And it just keeps going forever. Okay, next set, this stuff right here, -9 to 0. So -9's over here somewhere. It's not really important to get it in exactly the right place. Hard bracket means, all right, when I circle this, I'm going to shade it because it's including the -9. And this thing ends at 0. Looks like this. And the region here for that the and, because if this is an and, it has to be in both sets. That's from -9 to -1. So let's see how they wrote them before. Okay, so that's going to be the set from -9 to -1. Now we're going to be including the -9, but you notice again, this is not filled, so soft bracket on the -1. Okay, I'm going to leave it to you folks. Here's an example for you to try. You folks can work this one, and if you can't get it figured out, we'll talk about it in class. All right, let's chat about these things. Okay, solving inequalities. So here's my first thing I need to describe here. When you're solving an inequality, basically you can just treat it like an equal sign. All the things that you can do with the equal sign, you can do with equalities here. You can add things from both sides, multiply, divide, all that stuff. But there's one very important fact, okay? If you multiply or divide by a negative number, you must reverse the inequality direction to keep a true statement. So here's an example of that. Let's say, here's a statement that's true. 2 is greater than negative 1. Right, that is a true statement. Look what happens if I multiply that by minus 1 and I don't change the inequality direction. This would now read negative 2 greater than 1. And this is a false statement. Negative 2 is not greater than 1. But if I do reverse it, right, negative 2, reverse the inequality direction, less than 1. Now we have a true statement. So basically, when you're solving these things with the inequalities, just basically pretend like they're equal signs. However, keep in mind that anytime you multiply or divide by a negative number, you need to change the inequality direction. So let's look at a couple examples here. We can start this by subtracting 4 from both sides. And then divide both sides by 2. And that's it. And there's our answer right there in interval form. All right, take a look at this one. I'll go ahead and work this one out. So I'm just going to kind of pretend like, that's an equal sign for now. Probably distribute this, probably a good place to start. Maybe move the 5x over to the left by subtracting it from both sides. Move the 6 and the 3. And if you want to, I probably could have wrote that as 9. That's perfectly fine. If we subtract those, we get x greater than or equal to 7, I believe. Take 15 minus 6 minus 3. And that looks consistent with this. So we're happy. We move on. I'm going to leave this one, actually, this one right here as an exercise to you folks right here. Please have that done class time Monday. Okay. Now, here we have inequalities that are written slightly differently, where we have x kind of sandwiched between these two terms. So this is a pair of inequality statements. And one thing you can do with this is you can kind of solve it just the way it sits. You want to get x all by itself. Well, all we have to do here is add 6 to everything. So plus 6, plus 6, plus 6. And if we do that, the new line reads negative 1 less than or equal to x less than or equal to, not less than or equal to, less than 10. I'm just going to look at this here. I believe this is correct. I think this is another example here where I probably copied that thing down wrong. I got to work on that. What's happening there is I'm writing on one screen and getting the answers from another. I'll try to be much more careful about that in the future. I'm going to double check this one more time. Add 6. Yeah, I stand by this answer. So I'll let you folks work on this one, and it sure looks to me like this solution is correct. I don't think you have too much trouble with it. All right, so now dealing with these inequalities combined with absolute values. Here's where things start getting a little bit tricky. First of all, let me just kind of plop a number line on here for a moment. And just, I'm going to put a 0 here, and here's 4, and here's negative 4 over here. And just kind of do some inspection here. If I plop 0 here, you get a true statement because 0 is less than 4. So this works. 1 will work, 2 will work, 3 will work. Now 4 itself doesn't actually work because the absolute value of 4 is not strictly less than 4. If there was an equality here, 4 will work, but without the equality, it doesn't. 5 does not work. Absolute value of 5 is just not less than 4. Now this stuff over here also works. You put a negative 2 in or negative 3 by the time you absolute value it, you get something that does solve this thing. So anytime you have an inequality that kind of looks like this and you get less than some value, when you undo the inequality, there's really two things here. One possibility of x is positive, x is less than 4. However, the other possibility is that x is bigger than negative 4. And if we plot these things, You might wonder, where's this coming from? Because this thing right here, this term could be plus or minus. Could be either one. And if we undo it with a plus, we get this one. If we undo the absolute value and divide the negative sign out, we get this one. And when you look at this on a number line, we get -4, 4. This one looks like this. Circle at 4, arrow to the left. This one looks like this. Circle at -4, arrow to the right. This is the intersection point here. So when you undo one of these inequalities, there's going to be two statements, and the word that goes between these is and. Both of these have to be true. And there's our intersection point here from -4 to 4 written in that form. When we work this one, right, one possibility is x plus 1 less than or equal to 9. Right? And I'm going to put in here that x plus 1 has to be greater than or equal to -9. Both of these have to be true. This one has a solution x less than or equal to 8. This one has a solution x greater than or equal to, let's see, -9. Subtract 1, -10. I always like to kind of plop these on a number line. X greater than -10, here's -10. Circle filled in because of the equals, arrow to the right. This one, go over to 8, which is over here somewhere. Circle filled in because of the equality, arrow to the left. And this is the region where both of them are true. So that's the region between -10 and 10, including the endpoints. That's why the hard bracket. I'll let you folks try this one. And frankly, you can probably try that one as well. All right, I'm gonna talk about this one though, because this one is slightly different. Okay. So imagine here, before we do this one, let me make up a little short one here. Imagine this said absolute value of x greater than or equal to 6. Let's just start with that and look at it on a number line. Here's 0, 6. I'm going to put -6 over here. If you try any test point in this region, they are not going to work. 6 works because the absolute value of 6 is 6. That's greater than or equal to 6. 7 works, 8 works, 9 works. So one solution looks like this, anything to the right. Now, if we try -6, that also works. So this is a solution. -7, by the time you do the absolute value, you get 7, and that is greater than 6. Anything to the left also works. So in this case, anything that's over here, or, that's an important word here, over here is part of the solution set. So when you have greater thans here, you have to keep that in mind. You end up with these or statements instead of an and statement. So now, when we undo our absolute value, one possibility is 2x minus 4 over 3 is greater than or equal to 6. Or the other possibility, 2x minus 4 over 3 less than or equal to -6. Anything that fits either of those will solve this original line right there. So 2x minus 4 greater than or equal to 18. 2x minus 4, 2x greater than or equal to 22, so x greater than or equal to 11. Over on the right-hand side, we get 2x minus 4 less than or equal to -18. Now, this does not flip the inequality, because even though this is negative, we did not multiply by a negative number. We multiplied by +3, so that inequality direction stays put. 2x less than or equal to -14, by the time we add 4 to both sides. X less than or equal to -7. If we did this on a number line, by the way, I love number lines for this. 0, 11's over here somewhere, -7's over here. It's not important that you get them in exactly the right places. So this thing is saying 11, including the 11 to the right, This one is saying from -7 to the left. So here's the graphical representation of that solution, and here it is in, I guess that's called interval form. Moving on. I'm going to let you folks work both of these, all right, before class. Keep in mind this one right here. When you divide by the -3, that's going to flip the inequality direction. Then you're going to have two separate statements and solve each one. And you're going to end up with an and, by the way, not an or. I'm going to let you folks try this one as well. Keep in mind when you divide by the -2, you've got to reverse the inequality direction. This one right here is basically the same thing. And again, I think I'll let you folks work this out. I'd probably start by rewriting it. Square root 1 minus 3x greater than 6. That's the same statement right there. This one right here, all you have to do is subtract the 4 first from both sides and then undo the absolute values. I don't think you have too much trouble with that. Again, give her a try. If you can't get it, ask. Same thing here. And I guess I'll go ahead and work this last one out because there's no answer. So I'd start by subtracting 5, new line, square root of, absolute value of 7 minus x over 2 greater than or equal to, let's see, 21 minus 5. I guess that would be 16. Now, we undo the absolute value. One possibility is that 7 minus x over 2 is greater than or equal to 16. Or 7 minus x over 2 less than or equal to minus 16. Let's see. Going back to the first one, subtracting 7 minus x over 2 greater than or equal to 9. 16 minus 7. And then we're going to multiply by -2. So x less than or equal to minus 18. This one, we can get the inequality flip because I multiplied by -2. Over on the left, minus x over 2 less than or equal to, let's see, -16 minus 7. I think that's -23. Just going to check that. 16, 7. Yeah, that's right. Okay, we're multiplying by -2 again. So now we're going to have x greater than or equal to 46. Okay. Number line, 0, 46 is over here to the right somewhere. Not important that you actually get it exactly where it belongs. Greater than, looks like this. -18 is maybe about here. Again, that has equality, so close circle, arrow left. There's our answer in graphical form. Or we can write it in interval notation here. Minus infinity to minus 18. Hard bracket on the 18. Whoops. I'm going to get this video finished up here before I answer that. Or from 46 to the right. And that's that. I'm going to go ahead and answer that phone. Everybody, I hope that this video helps.